This is the notes for 2.4c parallel and perpendicular lines. For parallel lines, your slopes have to be the same. For perpendicular lines, you're given the definition that M2 has to equal -1 over M1. What that basically means is that whatever your slope is, you need to take that fraction, flip it, and change the sign. So for example, if your one slope is 3/4, your other slope would be -4/3. If your slope is -5/6, your other slope would be 6/5. Now, question 1, we're given a basic equation and we're asked to find the slope of a parallel and perpendicular line. The first part asks for parallel. Again, parallel lines must have the same slope. So since our slope is 6, we know that our parallel slope is also 6. Now, with the perpendicular, again, we said we flipped it and changed the sign. Since this is an integer, we know we just place it over 1. So now if we flip this, we're going to get 1/6. And then we change the sign. So since it's positive, our perpendicular is negative. Question 2 is along the same lines, except this time we're given an equation in standard form. So first thing we want to do is we want to change this into slope-intercept form, the y equals mx plus b. So to do this, again, we have -6x minus 4y equals 6. We know that the first thing we would do is, since we have a minus 6y here, that we would add it to the other side. So if we add that to the other side, we're going to have our -4y equals, this is a positive 6x, this is a positive 6 as well, so plus 6. And then finally, since we have a -4 on our y, we divide both pieces, or all three pieces rather, by -4. Okay, and if we do this, our y would just be y. 6 over -4, we're going to go ahead and leave it as -6 fourths x. Same thing with the y-intercept. At this point, we really don't need to worry about that. What we do need to do, though, is, since this is a fraction that is reducible, we want to reduce it. So -6 over 4 will reduce to -3 halves. So after a bit of rearrangement, we see that our equation is -3 halves x minus 3 halves. So at this point, since it's in the y equals mx plus b form, we know that our slope is what's in front of x, so it is -3 halves. If we look at, so now we can go back and start to answer our questions. The first one, which I'm going to go ahead and label as A, asks us for our perpendicular slope. Again, with perpendicular slope, we flip it and change the sign. So -3 over 2, we flip it, we get 2 over 3, and then since this one's negative, our perpendicular is positive. The second question, which I'm going to label as B, asks us for the parallel. All right. Again, the parallel slopes are exactly the same. So in this case, it's going to be -3 over 2. Okay, question 3 goes a little bit further. This time you're given an equation and you want to find a line that is parallel and perpendicular to it, That's going through specific points. So question A says, find the equation of the line perpendicular to the line and passes through 4, negative 2. Okay, so if we go back to our equation, it's 8. Again, it's an integer, so we can put it over 1. So now, to find our perpendicular slope, we know we flip it and change the sign, so we get negative 1 over 8. From here, we're going to start by using our point slope form of y minus y1 equals m x minus x1, and we're going to fill in what we know. Again, y1 comes from your point. So in this case, we have a negative 2. And again, since it would be minus a negative 2, we just go ahead and put plus 2. Our slope, we said, is negative 1/8. And our x, again, comes from our point, which we say is 4. From here, there's 2 steps you need to go to simplify your equation. The first is we distribute our negative 1/8 to get y plus 2 equals negative 1/8 x plus a half. Second, we have a plus 2 here, so we know we would subtract 2 from both sides, and we would get y equals negative 1/8 x minus 3/2. Question B says, find the equation of the line that is parallel to the line that passes through the point. Okay, so we're going to do essentially the same steps. So to start out, our slope, we know, is the same as the slope in our original equation, which is 8. We start with our point slope form of the equation. So we have y minus a negative 2, so it will become plus 2, equals our slope, parenthesis, x minus our x of our point, which again we're given as 4. So this is our equation, and again we run through the same 2 steps. We distribute the number in front of our parentheses. So we get y plus 2 equals 8x minus 32, because 8 times 4 is 32. Second, we subtract 2 to get a final answer of y equals 8x minus 34. So that is the notes for 2.4C, parallel and perpendicular lines.